Hello, my name is Antoine Augagneur and I work on LoRaWAN topics at Savoie-Mont-Blanc University. In this short video, we are gonna speak about clock synchronization. It is a LoRaWAN application layer messaging package. This package allows to synchronize the real-time clock of an end device to the network's clock. Let's see how it works. Alright, for this demonstration, we are gonna use some equipment. First, we have a STM32WL55 as end device. It is activated and works in class C. Then, there is a Nucleo F746ZG as gateway. The Impact community from Actility will be our network server for this demonstration. However, this demonstration also works with any network server providing the clock synchronization service. Lastly, there is a dashboard we have built at USMB. It will help us to send downlinks and analyze uplinks. Well, let's see how this dashboard looks like. On the top, there are sections that describe the clock commands that are possible to send to the end device. This not-read dashboard is connected to Actility network server with MQTT protocol. It allows to send downlinks and receive uplinks. At the bottom left corner, there is the downlink setup. We only need to set up the dev EUI, the port, and the payload. At the bottom right corner, there is an uplink analyzer. It will help us to understand payloads received from the end device. Alright, let's start the demonstration. At the beginning, the device is not on time. To get the clock right, it must send a clock synchronization request to the network server. However, it is possible to force it to send this request. We are gonna do this thanks to the force device resync command. Well, I fill the device EUI field, then I give the port we are gonna use. It is the port 202. Indeed, the LoRaWAN application layer clock synchronization specification precises that all clock commands must be sent on port 202. Lastly, I put the force device resync command in the payload field. And finally, I send the downlink. Immediately after receiving this command, the device does two things. First, it answers the command by sending an uplink with its current time. Of course, it is wrong, as we can see on the uplink analyzer. The second thing the device does is to ask the network server for resynchronization. Then, the network server synchronizes its real-time clock. From this point, the device is clock synchronized. To be sure that the resynchronization was successful, we are gonna send a new force device resync command to the device. So, I set up the command again in the downlink setup with the device EUI, the port 202, and the 0301 payload. And finally, I send the downlink. As we have seen previously, the device answers to this command by sending its current time. Fine, the time received is correct, as we can see on the uplink analyzer. So everything went well, the demonstration is successful. Synchronizing the end device clock can be very useful for several LoRaWAN applications, such as synchronous measurement or in multicast context, by example. To learn more about LoRaWAN, please feel free to check our website www.univ-smb.fr/LoRaWAN, and then thanks for watching.